No matter how much money you've got invested in your race car, when it comes to performance on the racetrack, it all comes down to the contact patch between your four tyres and the racetrack surface. And of course, the wheel alignment is essential to optimise that contact patch. We're here with James from JOTA Sport to find out a little bit more about wheel alignment, although admittedly, this is at the upper echelon of motorsport with our LMP2 race car. So James, getting that wheel alignment sorted out in the first place obviously starts here in the workshop. Now you've got a reasonably special setup that I want to talk through, and it starts with the surface that the car's set up on. It's not just on your normal workshop floor, you've got a very special steel plate that the car is set up on. Tell us what's so special about that.
Well, this surface table is checked every year, basically, so it's completely flat, and it's a good reference for us when we go to fly away, basically international races. This is a good benchmark to start with, and after every event it comes back, and we just know that the car is spot on.
So you've got a perfectly flat, perfectly level surface, so this is essential when it comes particularly to aspects such as corner weighting, which we're going to touch on briefly. But as you've just mentioned, you're doing your setup here in the workshop, then you're flying away to another event where potentially you're not going to have a perfectly flat surface. So how does getting your setup here done in the workshop allow you to confirm everything at the track?
Yeah, so basically what we do with our scales is that every scale is levelled, and then we use a starret to ensure that at the circuit we try and replicate this surface table as best as possible.
And then once you've got the car set up at the track, you can then compare your setup values from here in the workshop to what you're seeing at the track?
Yeah, that's it. And with a small tolerance, we then use that as our new baseline. So if there's a kilo or two out when we get to the circuit, we see that as acceptable, and then that is our baseline to then repeat throughout the event.
So with the alignment setup, you've just talked about the corner weights, and again we're going to come back to that, but the other aspects we're normally looking at here are camber and toe. So can you tell us, starting with camber, what are you using, what equipment are you using to measure the camber?
So we use a digital camber gauge, which is also zeroed, and we check the tolerances of that all the time. And that is basically placed against our setup wheel, and that is our reading basically that we take.
Now, actually, compared to how we would set up the alignment on a conventional road-going car, it's quite different because, as we can see here behind us, the car has no wheels on it. So can you just talk us through those setup plates and why you use those, how they work?
Yeah, basically it's a machine piece of billet, and we can just ensure that there's no deflection, and it's repeatable, so we eliminate the tyre, we eliminate anything that's movable, and essentially, yeah, that is it, just to eliminate any discrepancies and just be consistent with it.
Okay, so you've talked about the camber there, measuring toe. Now, again, coming from a road car background, particularly the hobbyist, enthusiast level, it's quite common to take your car along to a wheel alignment, a specialist where they may be using a laser or camera-based wheel alignment machine, and instead, behind me, you're using strings to set this up. Yep. Now, a lot of people might think on face value this sounds backyardish or pretty rudimentary, but again, you're operating at LMP2. This is very high-level motorsport, and strings are still acceptable. Can you tell us why you favour strings and how they work?
I just feel that they can be measured, and it's a quantity that can be seen, and obviously with flying around the world, it's something that can be constantly checked and zeroed, whereas with lasers, if you have a system that's complex and it goes out of tolerance, you're sort of in a position where you may not be able to rectify that or even spot it.
I think probably it's important to mention again at the hobbyist level, people are taking their car to a wheel alignment specialist. They don't have a portable laser alignment system, so that's fine, but the problem is there you can't make any adjustments at the track, whereas the string system affords you a lot more flexibility. Can you just talk about the principles behind string wheel alignment? Because what we're really talking about here is a way of accurately measuring the toe on each corner of the car. So how does the string system work, and how does it allow that to be measured?
Basically on our setup wheel we have a flag at the front and the rear of the wheel, and then we use just a conventional ruler, take a measurement off the front and the rear, and the difference is in our toe figure.
Okay, so you're measuring out from those little flags out to the string that you've got run down each side of the car. So the key point there as well is the two strings that you've got running down each side of the car must be absolutely parallel. Correct, so you've got a really special setup that's all machine particular to the car, so that you can just fit it and you know that those strings are set up correctly. Yeah,
that's correct. Yeah, so we have a zimmer front and rear, and then our ride height bars are then fixed to that set dimension. and that is our baseline again.
So that zimmer you just mentioned, this is a frame essentially that bolts to take up points on the front of the chassis in place of the front nose cone, and they're at the rear of the back of the transaxle. Is that correct?
Yeah, that's correct, yeah.
So it's ensuring every time the setup goes onto the car, you've got those strings in exactly the same location. Again, just making things nice and quick, repeatable and precise.
Yeah, that's correct. We do measure us, because obviously the bars are adjustable. We do check that measurement every time we set the car up just to ensure nothing's moved. And again, those lines are still parallel.
Okay, so we've talked about the toe and we've talked about the camber, and those are two of those main factors that the team may be changing at a race event based on the track that the car is competing on, and also the weather conditions. The other aspect that I just want to talk about briefly here is the corner weight. So you've got the car set up on some corner weight scales, so that's measuring the weight on each corner of the car. Why is that important, and what are you using that information for?
I think fundamentally weight distribution, how much rake's in the car I think is monitored by the engineers, and also from a braking performance perspective, if the corner weights are out and you have uneven corner weights across the front, you're going to get uneven braking, and then obviously that's not desirable.
So again, this is very different from our average road cars, where we can get quite a variation in corner weight, and it's not going to maybe be the end of the world. But with a car that's this precise, this well set up, if you've got a variation in the weight on each of the front wheels when you're hard under brakes, this could end up with one side of the car locking up for the other.
Yeah, that's correct, yeah.
Can you tell us what sort of tolerance you work to in terms of corner weight at the front of the car?
When we set the car up, we work to 1 kilo across the front. And it's less than 10 across the rear.
Okay, so these numbers, again, we probably would be struggling to chase with a standard production car just because of the general weight distribution in the car. You've got a car that's purely set up from the outset as a racing car, so everything's a lot closer right from the get-go.
Yeah, that's correct, yeah.
Now, off camera, we're also talking about setting up spare components. So once you've actually got your suspension set up correct, you're able to go through and measure the length of all of the push rods. So why is that beneficial? How does that help you?
Well, basically, we'll measure track arms, push rods, and camber shims, and then that allows us to set up our spare corners. So in the event of an accident in a race or any sort of damage, we can then basically fit our spare corners straight away and basically ensure that the car is set up. So you could fit something, and if it's not measured correctly, the car could go out and just not handle.
So it basically means that in the event of a minor accident where you're replacing a corner of the car, that you don't need to waste even more time than going through another setup before the driver can go back out.
Yeah, that's correct, yeah.
All right, last point I wanted to talk about there is the ride height, which you've mentioned. So is there a specification, first of all, on the minimum ride height for these cars that you have to stick to, or is this more a case of your own personal setup?
It's personal setup, but due to the skids underneath the floor, if the car is too low, they'll wear excessively below the limit and then will be excluded. So there isn't a minimum ride height as such, but the ride height is dictated by that skid wear.
That skid on the underside of the car, essentially it's a motorsport level plywood, for want of a better term. So you start with that at 25 millimetres thickness, and what are you allowed to run down to?
20 is a minimum.
Look, James, it's been great to get some insight into the car and that setup there. And again, while you're operating at the LMP2 level and your string alignment setup is definitely a little bit more extreme than what we see at the hobbyist and enthusiast level of motorsport, this is still something that is totally applicable to everyday street cars and those attending track day events. So thanks for the chat there.
No worries.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.